In the strange and intricate world of quantum physics, not all particles are bound by permanence. Among the most fascinating are virtual particles, ephemeral entities that flicker into existence for unimaginably brief moments before vanishing. Unlike ordinary particles, virtual particles cannot be directly observed, yet their presence is essential to the interactions of matter and forces. They are the unseen architects of reality, mediating forces, influencing energy, and shaping the universe in ways both subtle and profound. Virtual particles arise naturally from the uncertainty principle, a cornerstone of quantum mechanics formulated by Werner Heisenberg. This principle allows for temporary fluctuations in energy, enabling particle-antiparticle pairs to spontaneously appear from the quantum vacuum. Though these particles exist for mere fractions of a second, they exert measurable effects, influencing the behavior of electrons, quarks, and even entire atoms. The vacuum, often imagined as empty space, is in fact a seething, dynamic field populated by these fleeting entities. One of the most striking roles of virtual particles is in mediating fundamental forces. Photons, for example, can be thought of as being exchanged between charged particles via virtual particles, transmitting the electromagnetic force. Similarly, gluons, W and Z bosons, and even hypothetical gravitons can interact through virtual processes, allowing forces to propagate and particles to influence each other across space. Without virtual particles, the universe's forces would not operate, and matter would lack structure. They are the invisible threads connecting all things at the quantum level. Virtual particles also contribute to measurable phenomena such as the Casimir effect, where two uncharged plates in a vacuum experience a tiny attractive force due to fluctuations in the quantum field. Likewise, in particle physics experiments, the presence of virtual particles affects scattering processes, particle masses, and decay rates. Even the mass of the electron is partially influenced by interactions with the virtual particle C surrounding it. Though intangible, these particles leave indelible fingerprints on reality, shaping the properties and behaviors of matter in ways that are subtle yet profound. The concept of virtual particles extends beyond terrestrial experiments. In the early universe, these fleeting entities may have driven inflation, contributed to the distribution of energy, and influenced the formation of cosmic structures. Near black holes, virtual particle-antiparticle pairs at the event horizon play a role in Hawking radiation, allowing black holes to slowly emit energy and potentially evaporate over time. In this way, virtual particles bridge the smallest quantum fluctuations with the grandest cosmic phenomena. Highlighting the interconnectedness of reality at all scales, virtual particles also challenge our philosophical understanding of existence. They remind us that reality is not composed solely of tangible, observable entities but is shaped by transient possibilities, probabilities, and fluctuations. The universe is alive with temporary phenomena that, though fleeting, have lasting consequences. It is a cosmos where the ephemeral underpins the enduring, where the invisible orchestrates the visible, and where the briefest flickers of existence leave measurable effects on the grand stage of matter and energy. In high-energy physics, virtual particles provide the scaffolding for complex interactions. They enable the strong force between quarks, influence the weak decays of particles, and contribute to quantum corrections in the Standard Model. These particles illustrate that what is real in the quantum world is not always tangible. Sometimes, the transient and the impermanent wield the most power in shaping reality. The vacuum is never empty, and the fleeting virtual particles are the unseen engineers maintaining the universe's delicate balance. Contemplating virtual particles is to contemplate a universe more dynamic than intuition allows. It reveals a cosmos in which energy and matter are constantly in flux, where temporary fluctuations create enduring consequences, and where the fundamental forces operate through unseen intermediaries. These ephemeral entities remind us that the universe's structure, stability, and behavior depend on phenomena that exist for mere instants yet have infinite impact. In essence, virtual particles are the fleeting architects of reality. They mediate forces, shape matter, influence energy, and connect the visible with the invisible. Though they exist for moments too brief to measure directly, their presence underpins the cosmos, revealing a universe that is not static but alive with dynamic, invisible interactions. By studying virtual particles, physicists uncover the subtle threads of existence, gaining insight into the forces, symmetries, and hidden processes that define everything we see, feel, and know. They are proof that even the most fleeting phenomena can hold the power to shape the universe itself.